CPUs, fan cooling versus water cooling. It's no secret that as a machine functions, it generates a certain amount of heat into its surroundings, usually causing the machinery to heat up. It could be a PC, a laptop, a phone, or most other things you can think of. The CPU produces heat when in use, just like any other powerful piece of PC gear, and has to be properly cooled to operate at its best. As technology has evolved, fan and water cooling systems have been developed and improved with time. Both have their strengths and weaknesses. These facts give birth to an important question. Welcome to another video of the Modern Day Geeks. Today, what cooling system is the best for your PC? Water cooling or fan cooling? Let's find out in this video. In normal use, a CPU's transistors transform electrical energy into thermal energy, or heat as we call it. The CPU's temperature rises as a result of the heat. The CPU will reach its safe operating temperature if there isn't an effective channel for that heat. But how can you ensure that your CPU is running at the right temperature? The majority of desktops and laptops employ an air or liquid-based cooler, while there are other methods for cooling a chip. We'll discuss the differences between liquid cooling and air cooling, their advantages and disadvantages, and which could be best for your system. Let's have a brief look at how a CPU cooler even works. This is exactly what's going to help you decide. Basically, both air and liquid CPU coolers work by absorbing heat from the CPU and dispersing it away from the hardware. They both follow a similar operating concept. The CPU's metal cover, known as the integrated heat spreader, receives heat from the processor itself, IHS. The CPU cooler's baseplate receives the heat after that. The heat is then transferred to a fan, where it is expelled from the cooler and finally away from the computer, either through a liquid or a heat pipe. Even though the basic physics is identical, the two approaches use quite different strategies to redistribute heat. First, let's talk about an air cooler. In an air cooler, heat is carried from the CPU's IHS through the thermal paste that has been applied to and into a base plate that is often constructed of copper or aluminum and is hence conductive. The connecting heat pipes receive this thermal energy from the base plate. The purpose of the heat pipes is to transfer heat from one place to another. In this instance, the heat is transferred to a heat sink that is lifted off of the motherboard, making room for more parts like RAM. The tiny metal fins that make up the heatsink are supplied with heat via these pipes. These fins are made to be as exposed to colder air as possible, which allows the metal to dissipate its heat. After this, a connected fan helps push the warm air away. So, what about passive cooling? The building materials, copper is more conductive than aluminum for example, even if aluminum is more affordable, and the size and number of fans mounted to the CPU heatsink may all affect how efficient an air cooler is. This explains why there are differences in the size and layout of CPU coolers that use air. Though larger air coolers often disperse heat more effectively, they're not always feasible, particularly with compact form computers. We'll go through the benefits of air cooling in more detail later, but first, let's compare it to liquid cooling. Alright, so what's the deal with the liquid cooling process? Similar to air coolers, there are many alternatives available, but the majority may be divided into two groups: all-in-one coolers and specialized cooling loops. Although the underlying concepts of how liquid cools the CPU in both are the same, we'll mostly be focused on all-in-one or AIO coolers here. The procedure begins with a base plate that is attached to the CPU's IHS using a layer of thermal paste, much like air cooling. Better heat transmission between the two surfaces is made possible by this. The water block, which is intended to be filled with coolant, is a component that includes the metal surface of the base plate. As the coolant circulates through the water block, it absorbs heat from the base plate. After that, it keeps flowing through the system and ascends one of two tubes to a radiator. Fans linked to the radiator then disperse the heat from the cooler by exposing the liquid to air, which aids in cooling it. The cycle then restarts when the coolant enters the water block once again. But which one is the right option for you? When used appropriately, both cooling techniques are quite effective, although they perform best in certain situations. Here are a few things to think about before choosing. The price might vary significantly based on the characteristics you value the most. However, because they are often easier to use, air coolers are less expensive. Both products come in basic and premium versions. A more expensive air cooler could include better fans, a bigger heatsink, and other design possibilities. The radiator on a high-end all-in-one liquid cooler could be bigger. It might provide a combination of aesthetic and practical customization, such as software to regulate the lights and fan speeds. Depending on the functionality you need, air and liquid CPU coolers come in a wide range of pricing points. Even though installing an AIO liquid cooler is frequently more difficult than installing a regular air cooler, it's still not too difficult. The radiator, two hoses that cycle the coolant, and the water block are often all that are there. The additional stages entail attaching a water block, which is done similarly to installing an air cooler, and then fastening the radiator and fans so that surplus heat can readily leave the computer. The equipment is called all-in-one, or AIO, because the coolant, pump, and radiator are all contained inside it. Therefore, minimal supervision or upkeep is needed after installation. On the other hand, installing a bespoke loop necessitates more work and knowledge on the part of the builder. Although the initial installation procedure could take longer, the increased flexibility enables far more customization and the choice to add more components, such as a GPU, into the loop, if needed. When correctly designed, these more complicated custom loops may handle builds of various shapes and sizes as well. Although air coolers might be large, their mass is concentrated in one spot rather than being dispersed throughout your system. On the other hand, with an all-in-one, you'll need room for the radiator and will also need to consider things like the water block's orientation and coolant tube's alignment. To that end, a large air cooler might not be the ideal choice if you have a smaller construction. A smaller radiator or an all-in-one or low-profile air cooler would be more appropriate. Make sure you have enough room for your preferred cooling system when planning your upgrade or selecting your case, and that it can accommodate the gear you've chosen. Liquid cooling is often quieter than the fan on a CPU heatsink, especially when utilizing an AIO. Again, there are air coolers with fans made expressly to decrease noise, and changing the fan settings or choosing a different fan can affect how much noise is produced. However, because the tiny pump is frequently well insulated and radiator fans frequently operate at lower RPMs than CPU heatsink fans, liquid cooling generally produces less noise. If you're serious about overclocking or want to perform CPU-intensive tasks like generating video or streaming, liquid cooling may be the ideal option. Compared to pure conduction, liquid cooling spreads heat over a larger convective surface area, enabling lower fan speeds or higher overall power. To put it another way, it's more effective and frequently quieter. Liquid cooling is definitely the best choice if you want the lowest possible temperatures, if you're looking for a quieter solution, and if you don't mind a somewhat more difficult installation process. Although air coolers are quite effective at moving heat away from the CPU, you should be aware that heat is also transferred into the casing. The system's overall ambient temperature may rise as a result of this. Through the radiator's fans, liquid coolers perform a better job of transferring the heat outside the system. So, let's get back to the main topic of question: liquid versus air cooling. What is superior? The answer relies on your computer usage habits, as well as the performance and workloads you anticipate. Liquid cooling is the best option if you want the most effective cooling system and don't mind paying a higher price. Air cooling is an obvious choice if you're searching for a solution with more affordable upfront costs and straightforward installation at the possible cost of peak performance or acoustics. When choosing, take into account how you now use your PC as well as how you intend to use it in the future. Both are great solutions, but they are made for quite distinct use situations. You must choose which is best depending on your usage. However, the facts provided in this video should make the choice much easier. So, what cooling system are you aiming for? Water or air cooling? Let us know your thoughts, comment below. And oh, don't forget to smash that like button and subscribe. This has been the Modern Day Geeks, and we'll see you in our next video.